Hi, welcome to my channel. I'm Aravindan. This is the sixth lesson in electric field. Mainly, I focused on Edexcel, Cambridge, and International Baccalaureate syllabuses. Okay, we'll continue. This is the 10th question. Okay, here they are saying, parallel plates are kept like this in horizontal plane and they are connected to a DC power supply of EMF 500 volt. So upper plate will become positively charged and the bottom plate will become negatively charged. When you connect a DC power supply to parallel metal plates, the plate which is connected to the positive terminal of the DC power supply will become positively charged and the plate which is connected to the negative terminal of the DC power supply will become negatively charged. So there will be electric field between the parallel plates that will be from positive plate to negative plate. We know that always direction of the electric field lines are from positive to negative plates. Okay, so here what they are saying, an oil drop is floating in the region between the parallel plates. Actually, we do these things in an experiment. I'll describe that in a separate video that is called Milligan's oil drop experiment. Through that experiment only, Milligan was able to find the charge of an electron, right? So electron is an oil drop which is charged is floating in the region between the parallel plates, right? So they are giving the mass that is 2 into 10 to the power minus 4 kilogram. And the potential difference across the plates is given 500 volt and the plates are 20 millimeter apart. Okay, so the first part, find the charge Q. So it's better to say, can it be? Now, first we should think about what are the forces acting on the oil drop. Okay, the forces, there can be two different forces acting on it. The first one is the weight. Because if the only force acting on it is the electrostatic force, that will be the unbalanced force, then the oil drop won't be at rest. So there should be two forces. What are they? The oil drop has weight that is acting downward direction and the electrostatic force should act upward direction. Fe stands for electrostatic force that should act in upward direction. Okay, to balance the weight, right? So this should balance this one. So what type of charge does it carrying? Actually, oil drop is carrying negative charge because I told the upper plate is going to be the positive plate, right? So the oil drop is experiencing an electrostatic force towards the positive plate, means it should carry a negative charge. Or I can say the electric field lines will be from positive to negative plates. So the electric field lines will be their uniform field. So they will be from positive to negative. So we learned that in the previous videos, always negative charges experiences electrostatic force opposite to the field line. So that means it should experience electrostatic force upward direction, that is opposite to the direction of field lines. That means it must carry negative charge. Okay, because this is positive plate, because it's connected to the positive terminal. Okay, so it's simple. They asked to find the charge. First part, find the charge Q. The oil drop is carrying charge Q. So I can say like this, since it's at rest, I can say Fe must be equal to mg. But we know that Fe, the electrostatic force, is given by F equal QE. And also we know that in uniform electric field, E equal V over d, where V is the potential difference between the plates and D is the distance between the plates. In the previous video, I told that in a uniform electric field, if you consider 2 points, the distance between the 2 points, if it is D, and the potential difference between the 2 points is V, then electric field strength is given by E equal V over d, right? So here the distance between the 2 points are these 2 points. I can consider the points, any point on the plate and another point in the bottom plate. So the distance is 20 millimeter. The potential difference across the plates is 500 volt. Okay, so substitute all these things. So Fe, I can say QE equal mg, and Q, instead of E, I can put V over d equal mg. So I know all the quantities. I need to find the Q. So Q times potential difference is 500 divided by 20 millimeter, convert to meter, 10 to the power minus 3. I'm dividing it by 1000. equal to mass of the oil drop is given 2 into 10 to the power minus 14 into 9.81, that's the G. Okay, solve it. You will get the value for Q. That will be the charge. That will be 8 into 10 to the power minus 18. 18 to 10 to the power minus 18 Coulomb. That's the magnitude. But I know that should be a negatively charged particle, oil drop. So that should be minus 18 to 10 to the power minus 18 Coulomb. Okay. So second question. What will happen to the oil drop when the plates are slightly moved closer to each other? So you are moving the plates slightly closer to each other. Maybe now it is 20 millimeter. Maybe the gap between the plates becomes 18 millimeter, something like this. They are bringing them closer to each other. What will happen? Okay, so since the voltage across the plates remains unchanged because 500 volt. So V will remain unchanged. So D is decreasing. Electric field strength will increase. Okay, when you bring the plates closer to each other, the electric field strength in the region between the plates will increase. Okay, electric field strength will increase. The charge of the oil drop is not changing. It's remaining unchanged. So Q is remaining unchanged. E is increasing. So the electrostatic force on the oil drop will increase, which is upward direction. Earlier, the electrostatic force is able to balance the weight. Now the electrostatic force is increasing, means it's going to be larger than the weight. So upward force will become larger than weight, means the oil drop will have a unbalanced force in upward direction. So it will accelerate upwards. Don't say it will move upwards. You might lose marks. Okay, because when there is a unbalanced force, according to Newton's second law, the oil drop will accelerate. So it's going to accelerate upward direction. That's the answer. Okay, so this is the second question. Here, two parallel plates XY and LM are kept in horizontal plane, 20 millimeter apart, and they are connected to a DC power supply of 2400 volt. Okay, so here also the plate XY is connected to a positive terminal and LM is connected to negative terminal. So XY will be positively charged and LM will be negatively charged plate, right? So here what's happening, the question is slightly different. Here they are saying an electron is released from a point closer to LM. Maybe electron is released from a point somewhere here, very closer to LM. So when the electron is released from LM, what will happen? The electron is going to experience upward electrostatic force. We take downward gravitational force, but normally, the gravitational effect on electrons, protons, alpha particles are negligible, very small. So in these type of questions, we don't need to consider the force due to gravitational field. Mass of the electron is 9.11 10 to the power minus 31. So the weight will be, if you multiply this by 9.81, say just 10 if you multiply, it will be 9.11 10 to the power minus 30 Newton, very small. We can ignore the gravitational effect on particles such as electrons, protons, or alpha particles, even atoms. Okay? We can neglect the gravitational effect. But when we consider the previous question, there is oil drop. So there, oil drop is floating, means in the previous question, electrostatic force must be balanced by the weight, right? But here we ignore the weight of the electron. So they are saying electron is released from the point closer to the LM, the plate. So electron will accelerate. It's going to have an unbalanced force upward. That will be the electrostatic force. So the electron will accelerate towards XY, because the electric field lines will be downwards, is it? Electric field lines will be downwards. So it's going to accelerate upward direction. So this is the electric field lines downwards. Electron will experience opposite to the direction of field line, right? So first part, find the electric field strength between the plates. Okay, so the find the electric field strength in the region between the plates means that we know that first part E equal V over D. We know that. So Electric field strength is given by V over D. We know the potential difference, that is 2400, and the distance is 20 millimeters, so 20 into 10 to the power minus 3. Solve it. You will get the electric field strength. That will be 1.2 10 to the power 5 10 to the power 5 Newton per Coulomb. Okay, that's the electric field strength in the region between the parallel plates. Okay, second part, find the acceleration of the electron. Okay, so I told already the electron is going to experience only one force, actually two forces. Gravitational force is negligible. So the only force acting on the electron is the electrostatic force. So that will be upward direction towards the positive plate. So I can use Newton's second law, F equal ma. So F equal ma, if I use, F is the resultant force, that will be the electrostatic force. We know that electrostatic force is given by F equal QE. Q is the charge of the electron, E is the electric field strength, we already found it. So F I can substitute, QE. So Q is 1.6 10 to the power minus 19 into electric field strength 1.2 10 to the power 5 times mass is 9.11 10 to the power minus 31 times A. So find the acceleration. Okay, so you can find the acceleration. That will be equal to 2.16 10 to the power 16 meter per second. 2.16 10 to the power 16 meter per second. Okay. Right. Okay. So third part, find the time taken by the electron to reach the plate XY. So it's going to accelerate towards plate XY. So they ask me to find the time taken. So there I can use, electron is released. They are saying just release means initial speed, we should take the initial speed 0, right? Just released, right? So the initial speed is 0. So the electron is accelerating from LM to XY. So when it reaches the XY, the distance moved by the electron is 20 millimeter, and it has a constant acceleration 2.16 10 to the power 16. So it will move on a straight line. So it will move on a straight line with constant acceleration. So I can use equations of motion, right? Whatever you learned in mechanics, the equations of motion I can use S equal ut plus half at square. I can use towards plate XY. So S is going to be 20 millimeter, 20 into 10 to the power minus 3. Initial speed is 0, half into acceleration is 2.16 10 to the power 16 t squared. So initial speed is 0. Solve it. You will get the time taken to reach the plate XY from LM. That will be 1.4 10 to the power minus 9. 1.4 nanoseconds. Okay, so this is the 12th question. The previous one was the 11th one. So here they are saying XY and LM are parallel metal plates kept 4 centimeter apart, and the voltage across them is V. It's an unknown, not given, right? So this is the positive plate because you know positive terminal. This is the negative plate because that's the negative terminal of the DC power supply. An electron is moving at a speed of 4 into 10 to the power 6 meter per second along parallel to the metal plate. So it's moving parallel to the metal plates along the mid region of the plates, So, and finally, you know, when the electron after it enters into the plate, it's going to experience an unbalanced force due to electric field in upward direction. Gravitational effect is negligible on an electron, right? So the only force acting on the electron is the electrostatic force that will be towards the positive plate. So the electron is turning and hitting the plate XY at a point N, which is 6 centimeter from X. Okay, which is 6 centimeter from X. Right. First part, find the time taken by the electron to reach the plate XY. So that means, after it enters to the plate, the region, right? From the time it enters into the region, how long it takes to reach the point N. Okay. This is something related to something I can analogy. I can compare this with the normal projectile motion what you learned in mechanics. Now, when you throw a ball horizontally, I'm talking about under gravitational field. If you throw a ball horizontally, the only force it experiences is the weight. So the ball will bend down and hit the ground finally. You would have done that in mechanics, right? Same way, so there, when you consider the gravitational field is vertically down, the weight is acting vertically down. Here the electrostatic force is upwards because electric field is vertical plane. So the vertical vector has no horizontal component. You know that whenever you resolve a vector through 90 degree, it won't have any component in that direction. When a vector is resolved through 90 degree, it won't have any component, is it? So the electric field lines are vertically downwards. Yeah. So vertical vector won't have any horizontal component, means in the region between the parallel plates, there is no electric field in horizontal line. So there won't be any electrostatic force in horizontal direction. Parallel to the plates, there won't be any electrostatic force. So when an electron moves from, after it enters into the region from this point to N, until it reaches the point N, the electron will not experience any electrostatic force in horizontal direction. So in horizontal direction, there is no force. So the velocity 4 into 10 to the power minus 6 in horizontal direction will not change. It will remain constant, and horizontally no force means horizontally no acceleration, right? So when it moves from this point to this point, the horizontal displacement is going to be 6 centimeter. Horizontally no acceleration, something like a projectile motion. So first part they ask me to find the time taken. So here I can find the time taken by using S equal ut plus half at squared equations of motion in horizontal direction. For the motion, I can name that from the point when it enters, from the time here, I can say this name, I can say that as K, from K to M, right? From K to M. K to M, I'm using S equal ut plus half at squared horizontal direction. Horizontally, no acceleration because horizontally no electric field, so no acceleration. So S is 12 centimeter, 6 centimeter. 6 into 10 to the power minus 2 convert to meter. The speed is the same. It won't change in horizontal direction. Initial speed will be the same for throughout the motion. 4 into 10 to the power 6 into t plus half times no acceleration 0. So solve it. You will get the time taken by the electron to hit the plate N from the time it enters into the region between the parallel plates. So you will get the time that will be 1.5 10 to the power minus 8 seconds. Okay, second part they're asking find the acceleration of the electron when it moves between the plates. Okay, so first students immediately when they read this question, immediately they get the idea F equal ma. Yes, there's nothing wrong. F equal ma, then you should know the F, that will be the electrostatic force. Then electrostatic force F equal QE. Okay, we'll try. Will I be able to get that answer if I go in that part? In the exam hall, you might get idea immediately, something like that, is it? So I'll get, so for example, say I got an idea, okay, when I saw that, I know Newton's second law, I'll try to use F equal ma, right? So F is the resultant force, that will be the electrostatic force. So immediately students thinks electrostatic force equal ma, that is in upward direction. So electrostatic force equal QE, yes, good. I know the charge, I don't know the electric field strength. If I want to find the electric field strength, then I should have an equation. I should use the equation E equal V over D. Okay, now I am going to be in trouble because if I try this way, electrostatic force equal QE and MA Q into, instead of E, if I substitute V over D equal MA, if I try to use this method to find the acceleration, I know the Q, I know D, I know the mass, but V is not given. So I'll be in trouble. In this equation, there are two unknowns, so I won't be able to find the acceleration. So if you try this way, there's nothing wrong in the method in terms of physics principles. There's nothing wrong, you are right, but you won't get marks because you won't get the answer. So the only method here, use the mechanics again, equations of motion, right? There's nothing wrong, but you won't get the answer in this question because the data, the V is not given. So no point of continuing this method, right? So I use the equations of motion. What's the idea? Okay, after entering the plate, so they are saying the electron is moving along the mid region. So mid region means, you know, the bisector of this, the central part, central region between the plates. So when it moves from K to N, it completes a vertical displacement. How much? 2 centimeter. So when it is moving in the region between the plates, I told there is no electrostatic force in horizontal direction. The only force is vertically upward direction. So at the moment when it enters into the plate, at that moment, say for example at point K, that's a starting point of the region between the plates, at that point the vertical component of the velocity is equal to 0 because they are saying that it's moving parallel to the plate. Somewhere they said, yeah, parallel metal plates kept in horizontal plane. An electron is moving parallel to the plates. So if the electron is moving parallel to the plates means velocity is parallel to the plates. So the vertical component of the velocity initially when it enters into the plate at K, the vertical component of the velocity will be equal to 0. When it hits the point N, the vertical displacement is 2 centimeters and the acceleration due to the electrostatic force, that will be upward direction. So I can use the equation S equal ut plus half at squared upward direction. From, if I mark it on the diagram on my answer paper K, I can use that equation from K to N for the motion from K to N. K to N in vertical direction, right? So the vertical displacement when it hits the N is going to be 2 centimeter, 2 into 10 to the power minus 2. The initial speed when it enters into the region in vertical direction is 0 plus half A into time. I already found it, 1.5 10 to the power minus 8. That's the time taken to move from K to N. I used the horizontal displacement. I found it. That will be the time to move vertical displacement also. Is it? Like a projectile motion. Solve it. You will get the acceleration. That will be vertically upwards. You will get acceleration 1.78. Check your answers. Yeah, 1.78 10 to the power 14 meter per second squared. Okay, third part. Find the resultant force on the electron. So that is when it moves from K to N. So I don't need to spend much time on it. I already explained several times the resultant force will be the electrostatic force, right? So, but in this question, I can't use again F equal QE. So I'm going to use Newton's second law because voltage is not given. Since I know the acceleration, I can use upwards F equal ma. So that is the resultant force. That will be the electrostatic force. Mass is 9.11 10 to the power minus 31 times acceleration is 1.78 10 to the power 14. So solve it. That will be the upward resultant force, 1.62 10 to the power minus 16 Newton. That will be the resultant force on the electron. Okay, so fourth part, find the voltage across the plates. Now only we are going to use equation related to electric field. So far, we were using equations of motion and Newton's second law. So here only they are asking to find the voltage across the plate, that is V, right? I know the resultant force acting on the electron. Third part I found it. That will be the electrostatic force because gravitational effect on the electron is negligible. So if I consider the fourth part, the resultant force will be the electrostatic force, that is F that is going to be the electrostatic force that is equal to QE, but E equal V over D. So electrostatic force is given by 1.62 10 to the power minus 19, 1.62 10 to the power minus 16 equal to the charge is 1.6 10 to the power minus 19, that's the charge of the electron, into we need to find, that's a quantity they asked to find. The distance is 4 centimeter, convert to meter 0.04. So find the V. So we'll find the V will be 40.5. Check your answers. 40.5 volt. Right. Okay, so in this question, slightly different compared to the previous one, 11th question. Compared to that, this is slightly different. So here the voltage across the plates is given 100 volt. And the plates are kept in horizontal position. Length of the plate is 12 centimeter. Both are 12 centimeter length, both plates. An electron is entering along the mid region parallel to the plates at a speed of 6 into 10 to the power 6 meter per second, right? And the distance between the plates is slightly different compared to earlier, 5 centimeter now. Okay, the question is find the force on the electron when it moves between the plates. So several times I told I can neglect the gravitational force. So even if they ask find the force, that will be the resultant force here because that's the only force, electrostatic force. So here I don't need to I don't need to follow Newton's second law or anything because I know the voltage across the plates. I know the charge of the electron, right? It's not given. Charge of the electron, you know that is given in all the exams they give it. Mass of the electron is 9.11 10 to the power minus 31 kilogram, and charge is minus 1.6 10 to the power minus 19 coulomb. That you can get it anywhere, right? So since we know the charge of the electron negative, it will certainly move upward direction. The force will be upward direction. So first part, I can say the force that is going to be the electrostatic force, that will be QE, and E equal V over D. So charge is 1.6 10 to the power minus 19. The potential difference is 100 volt, 100 over distance is 5 centimeter, 0.05. So the electrostatic force on the electron will be 3.2 10 to the power minus 16 Newton. That's the answer for the first part. Okay, second part, find the acceleration of the electron. So that is nothing. We know, since we know the force acting on the electron, I can find the acceleration of the electron by using Newton's second law, F equal ma, that is 3.2 10 to the power minus 16 in equal to mass of the electron given 9.11 10 to the power minus 31 into A. Find the A. So that will be 3.51 10 to the power 14 meter per second squared. That will be towards the plate XY. Towards the plate XY. Is it because the force will be upwards, so the acceleration also will be upwards. Okay, so the third part is slightly different. They are not asking to do any specific calculations, right? They are not asking to do any specific calculations. They are asking, will the electron hit the plate XY? So, you know, when it enters into the region between the plates, the electron is going to turn, the direction of motion is going to turn towards XY. So there are two possibilities. It can hit the plate XY somewhere here like this. It can hit the plate, something like the previous question, or it can move out of the plates without hitting, but it changes its velocity, changing its direction, what will happen? Right. Okay, so here first you should decide how can I confirm that, what calculations should I do? Okay, so I can do like this. I'm getting idea like this. Okay, if it hits the plate, that means the horizontal displacement it completes is not equal to 12. Careful, I am taking this idea. If it hits the plate somewhere here, point N, between X and Y, if the electron hits the plate, then it's completing two different displacement. What are they? The first displacement parallel to the plates, okay, that will be less than 12 centimeter, and the displacement towards the plate will be half of it because it's moving along the mid region. So the displacement towards XY will be 2.5 centimeters. So when I do some calculations, if I get an answer like this, when it completes a vertical displacement 2.5, right? That means when it completes a vertical displacement 2.5, if its horizontal displacement is less than 12, that means it is hitting the plate. That is one approach I can do. When it completes a displacement vertically 2.5 centimeters, if the horizontal displacement is less than 12 centimeter, that means it will hit the plate XY. That is one approach I can do. Second approach, by using time, I can do that by finding two different times. What are they? How much will it take to escape out of the plate? That means if it wants to complete horizontally 12 centimeter, what's the time required? I can say that time T1 or TH. The time taken to complete horizontally 12 centimeters, the time taken is TH. I can find it. Then I can find what will be the time taken to hit the plate by moving towards the plate 2.5 centimeters. How much will it take to hit the plate? If it wants to hit the plate, it should move towards the plate, right? 2.5 centimeter. So what will be the time for that to move 2.5 centimeter towards the plate TV? Right. By comparing these two time, I can give the conclusion. If TV, the time taken to reach the plate is smaller than TH. If TV is smaller than TH means this will happen first. That means before escaping out of the plates, it will make the plate XY, right? If TV, that is time taken to reach the plate, if the time is larger than TH, that is the time taken to complete horizontally 12 centimeters is smaller than the time taken to reach the plate XY, then the smaller time will happen first, is it? So this will happen first. That means it will complete 12 centimeter before completing towards the plate 2.5 centimeter, it will go out of the plate, right? Either method I can follow. Okay, I'll do the first method. Second method you try it. I'll tell you and leave it. You can try it. So first method, I'll do like this. Third part. I already found the time taken to complete. No, I didn't find it. So horizontal I can use S equal UT plus half AT squared. So the time, the displacement to come out of the plate, 0.12 equal to, the initial speed is 6 into 10 to the power 6 into t plus horizontally no acceleration, because I told several times horizontally there is no electric field, so horizontally there is no acceleration. So the time taken to complete horizontal displacement will be, solve this one, you will get the time taken, that will be 2 into 10 to the power minus 8 seconds. So this is the time required. I can call this as TV, yeah. Sorry, TH, the horizontal. So I can call it as TH, time for horizontal displacement. TH, I'll name it as TH. So time taken to complete horizontal displacement of 12 centimeter to escape out of the plate, that is going to be 2 into 10 to the power minus 8 seconds. Same way, If it wants to hit the plates, it should complete vertically towards the plate 2.5 centimeters. So I'll use vertically is equal ut plus half at squared. So that is 2.5 10 to the power minus 2 equal to, initial speed in vertical direction is 0 because the velocity is parallel to the plates. It has no vertical component, plus half into the acceleration. We already found it in the previous part, and the acceleration is, we found it as 3.51 10 to the power 14, 3.51 10 to the power 14 into t squared. We solved it. The time for vertical displacement of 2.5 centimeters, that will be 1.19 into 10 to the power minus 8 seconds. See, now TV is less than TH. That means this will happen first. Is it? This will happen first. So it will hit the plate. So I can say it will hit the plate. Okay, so that's enough. That calculation is acceptable because since the time taken to complete 2.5 centimeters smaller than the time taken to escape between the plate, through the plates or out of the plates, it will hit the plates. Okay, so the same question, method 2, I can do like this. Find the time taken. Say if it wants to hit the plate XY, it must have a vertical displacement toward plate XY 2.5 centimeter. Already we found that time. I'll find it again. That means if we want to hit the plate, it should move vertically towards XY 2.5 centimeter. Find the time taken for that by using S equal ut plus half at squared. So S is 2.5 10 to the power minus 2. The initial speed towards the plate is 0 equal half into the acceleration. We already found it, that is 3.51 10 to the power 14 t squared. We found the time for that, that is 1.19 into 10 to the power minus 8 seconds. Okay. Now I can find, okay, during this time, what will be its displacement horizontal direction? If that displacement is more than 12 centimeter, that means it has escaped. Okay. Otherwise, if it is less than 12, it's going to hit the plate. So first method I proved it, it's going to hit the plate. Now this is second method. I'm going to use the horizontal displacement. I'm going to find the horizontal displacement during this time by using S equal ut plus half at squared. That is the horizontal displacement, SH. That will be, the speed is 6 into 10 to the power 6. Time to hit the plate, or if it wants to complete vertical motion 2.5, that is, this is the time, 1.19. 10 to the power minus 8 plus half. Horizontally, no acceleration because there is no electric field in horizontal direction. Solve it, you will get 0.0714, I think, yeah, 0.0174 meter. Convert to centimeter, that will be 7.14 centimeter. That is less than 12 centimeter. So what's going to happen when it completes vertically 2.5 centimeter, horizontally it's completing only 7.4, which is less than 12. So it will hit the plate XY. Okay. Okay, so in my next video, I'm going to discuss about electric potential, equipotential surfaces, work done in electric potential, those things. Little, it's actually for Edexcel syllabus. It's a new syllabus, is it? According to that, this the 2021 batch will be the second batch, I think. Yeah, second or third batch. Yeah. So it's a new current. You can't find much questions in past papers in Edexcel, but Cambridge IB you can find many questions related to electric potential. Okay, so we'll do that in the next video.